Okay, so today we're going to be talking about imaginary numbers. So, what happens if we have, for example, the square root of -4? So the square root of -4 we know is not real. We say it's not real. That's where imaginary numbers come into. It's actually an imaginary number. So we have a way to write this. So we write all imaginary numbers as a plus bi, where I, this is the imaginary part, and this can be a real number, and b is a coefficient for I. So what is I? So I, the square root of -1 is equal to I. Okay, so if we have, for example, the square root of -4, what we can do is we can rewrite this as the square root of -1 times the square root of 4, which would give me I times the square root of 4, because we know that this part is I, and we know what the square root of 4 is. The square root of 4 is 2, so it becomes 2I. Usually we write the I after the coefficient. So, for example, if you've got the square root of -36, that would become 6I. The square root of, let's say we had now the square root of -24, right? That we know would be I times the square root of 4 times the square root of 6, which is 2I root 6. Okay, so it really works the same as simplifying with I works very similarly to simplifying with non-imaginary square roots. Just some things to know about I. We know that the square root of -1 is I. Okay, if I had, for example, I squared, we know, is the square root of -1 squared. If I have I to the third, that's I squared times the square root of -1. I to the fourth, which is I squared, which is actually going to be just 1. If we take a closer look at each of these to see what they mean, if I were to take the square root of -1 squared, that always gives me whatever I have back inside. So that's actually -1. If I were to look at I squared times I, really, because this is I squared times I, we know I squared is -1. So this is going to be -1 times I, which will give me -I. I squared, you should be able to see that that's 1, right? Because this would be, if I erase this, if we look at this for a second, we know that I squared is -1 squared is 1. So, in summary, we've got I squared is -1, I cubed is -I to the fourth is 1. Now, what keeps happening? Well, what's amazing about I is that as you keep going, for example, if you were to calculate I to the fifth, right? I'm going to put a little box around this. I to the fifth, well, we know that that's I to the fourth times I. Well, what was I to the fourth? I to the fourth is 1. So this becomes 1 times I, which is just I. Okay, what about I to the sixth? I to the sixth is going to be I to the fifth times I, which we know I to the fifth is I. I times I is I squared. Oh, well, okay. So I'm going to have I to the fifth is I. I bet I to the seventh we can predict. I to the seventh it's going to be I to the sixth times I. I to the sixth is I squared. Times I is I to the third. And I to the eighth is going to be I to the seventh times I, which is I to the third times I, which is I to the fourth. Oh, so look, now I've got, again, I squared, I to the third, I to the fourth. So if you keep doing this, if you keep going by powers of I, what you're going to see is that they're all some form of I squared, I to the third, I to the fourth. So, for example, you might be asked by a teacher, find I to the 86th. Okay, so how do I do this? So what you do is you take 86 and you divide it by 4. Okay? So for those of you who are good at mental math, I apologize, but for those of you who are not so good at mental math, maybe you need to do this. Although I would think about the fact that we know 4 goes into 80, so then 4 has to go into 84. So what the remainder will be 2, but we know it'll be 80. We know it'll go into 84 with a remainder of 2. But for 86. So if you don't know, we know it goes into this, subtract 6, 1, 4, remainder 2. Now actually, what the most important part about this is the remainder. The remainder is what we use to figure out what power of I this is. If this has a remainder 2, if it has a remainder 2, then what we know is that this is actually the same as I squared. We know I squared is really -1. So the answer is -1. So if there's a remainder 3, we know it would be I to the fourth. If it's a remainder 4, we know that that would be the same as I to the fourth. Remainder 1 would be I to the first. And what you do is you always take this number and you divide it by 4. And whatever the remainder is, that's what power of I you get. Okay? So this is, again, just a brief tutorial. For more whys, maybe you can ask your teacher. But this is a brief tutorial. Okay. So what happens, for example, when I'm solving a quadratic equation, and I might get, for example, let's say we start out with some quadratic equation, we get down to the bottom, and we see we get 7 plus or minus the square root of -40 all over 2. Well, for some of you in your mathematical careers, this might be the answer you leave. Or you might even say there are no real solutions. But for those of you who have studied imaginary or what we call complex numbers means A plus BI, we know, so just a reminder, complex numbers are A plus BI, where this is the imaginary part. This is the real part. Okay, so now you might have to write, okay, well I know that this is 7 plus or minus. I can pull out that I times the square root of 40 all over 2. But we know the square root of 40 is really 2 root 10 over 2. A lot of teachers will prefer you to write it like this. And that would be your imaginary solution for that. There's a lot of things that we do with complex numbers. If you have, for example, so we write this as the standard form. Okay, so for example, I can multiply these. I just FOIL them like anything else. So I'd get 21 minus 14i plus 6i minus 4i squared. So I you can treat like a variable. So negative 14i plus 6i, negative 14i plus 6i, we know then becomes, what's 14? You can either do 14 minus 6 and make it negative, or, which is what I usually do, so that's negative 8i. So 4i squared, well, what was I squared? Remember, I squared is negative 1, which means that this is 21 minus 8i minus 4 times negative 1. Right? So that is how you can multiply. If, for example, I have something like this, we don't like this. We don't like having i's in the denominator. We want to rationalize it. We don't like having things that are not rational in the denominator. So what we do is we multiply this by the top and the bottom by something called the complex conjugate. The complex conjugate. The complex conjugate, for example, if I have a plus bi, the complex conjugate is a minus bi. The conjugate means basically whatever I need to multiply something, a complex number by, the complex conjugate, if you multiply this by its conjugate, you'll get a real number. So what do I mean by that? Well, what happens? For example, let's say I've got right? When I multiply these, I get 25. So minus 20i plus 20i, those will cancel. So these will actually cancel, and I'll be left with 25 plus 16, which we'll see is a real number. So a conjugate is whatever you multiply something by to make it real. The other way to remember it is if this one has a plus sign, then the conjugate has a minus sign. So these numbers are all the same, but the sign in the middle is different. So if I go back to right, we want to rationalize the denominator. So what I'm going to do is I'm going to actually multiply the top and the bottom by the conjugate. So that becomes now remember, the middle terms will cancel out here. I can just go to remember, treat the i's like they are a variable. Okay, so generally when we write things in standard form, a lot of teachers really want it to be in standard form, which really means a plus bi, which means that you have to separate this fraction. And that would be your complex number rationalized with no irrational or non-real numbers in the denominator. So that is a brief tutorial on imaginary numbers.